Hi ladies, so this recording is to help you in your virtual lab, mostly to calculate the period of your spring mass system. So it's a little complicated because if you notice, if I put this 100 grams on the spring, it's going to keep bobbing up and down forever and ever because I've set no friction in the spring, meaning all of that energy is just going to get translated between potential and kinetic. So let's go ahead and get rid of some of that energy by going over to lots. So when you first start your experiment, you want to make sure that your friction is set to lots so that way your spring reaches its new equilibrium point. And we're going to set it right here at about 10 centimeters, which is great. And then I'm going to set this dashed line to the top of that ruler. So what this dashed line is, this is going to be my marking point. This is where I'm going to start counting my cycle and where my cycle is going to end. I also have the stopwatch here, so that way I can time it. Now I'm going to switch my friction back over to none because I actually want it now to go on forever and ever. But because it's already been calmed down, it's not going to do it. So when we want to set this system in motion, we never stretch. We always want to compress. The reason for this is you want to make sure that you don't compress the spring beyond what it's possible to compress. If I was to compress it beyond what it could do, my mass would actually fly off and my spring has the potential of being damaged. So I'm going to compress it down to that dash line, that 10 centimeter area. And then when I let go, it's going to go ahead and start oscillating back and forth. Now, to count a cycle, I want to count the amount of time that it goes from the dashed line all the way down and back to the dashed line. That's going to be one cycle. Now, if you notice, it's kind of going a little fast for me. So what I'm going to do is I'm going to slow time down by hitting quarter time. This way I can clearly see when it hits it. If I want it to be even slower, I can go to 1/16th time to really make sure that I have it. But quarter time should be good. And what we're actually going to do, if you notice in your table, you have time of 10 cycles. We're going to time how long it takes to complete 10 cycles. So I have my handy dandy stopwatch here, and I'm going to start the stopwatch when it hits the dash line, and I'm going to stop the stopwatch after it's hit the dash line 10 times. So here we go. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now, if you notice, the stopwatch did not move at quarter time. It moved at real time. So the number that I would need to place into my table would be a quarter of this, or divide this by 4. Then to find the time of one period, you would take the time it took to complete 10 cycles and divide that by 10.